So far in Unit 1, Matter and Nuclear Chemistry, we have looked at pure substances and mixtures, how to tell the difference between those, how matter is classified. We have looked at chemical and physical changes in matter. We have looked at the atom. We've looked at the parts of the atoms, their locations, how to find their different particle numbers using the atomic mass number and the atomic number on the periodic table. Today we're going to look at standard SPS 1A, which regards atoms with different numbers of neutrons or isotopes. So we're looking at isotopes. Our question is, what is the difference between an atom and an isotope? So let's just review very quickly at what an atom is. An atom is the basic building block of all matter. It has not bonded with another atom or element. This means that this is the neutral atom. It has an equal number of positive protons and negative electrons that you see on the periodic table. There are only 118 known atoms at this time, and these 118 atoms can either bond together or mix to make up all of the substances known to man. These 118 atoms are organized on the periodic table of the elements. Inside the nucleus, the atomic mass of an atom, you have to make the relationship. The atomic mass of each atom on the periodic table basically tells you what is inside the nucleus. So you have your protons, which have positive charges and are equal to the atomic number. Then you have your neutrons, which have no charge, in which we practiced mass minus atomic number gives you the number of neutrons. And outside the nucleus of the atom, of course, you have electrons, which are negatively charged, which are also the same as the atomic number. So if the atomic number is 5, you have 5 protons, you have 5 electrons. The number of protons and electrons in an atom are the same. Again, that's represented by the atomic number on the periodic table. And an atom becomes unstable if the outer energy level of electrons is not complete. So how do isotopes occur? Isotopes are created when the nucleus of atoms are unstable and they begin to decay. This typically happens in the bigger atoms like number 92 and above on the periodic table, but it can also happen in smaller atoms such as carbon, oxygen, and hydrogen. Isotopes, again, are atoms of the same element with different mass numbers. This means if they have different mass numbers, then it means it's the same atom, but it has a different number of neutrons, okay? This is the nuclear symbol for carbon that you find on the periodic table. And you may remember that this number in the lower left is the atomic number, so that means there's 6 protons and 6 electrons. And the mass number for carbon, as it is on the periodic table, is 12. So if you take your mass number, subtract your atomic number, that tells you that you have 6 neutrons. So as it appears on the periodic table, the notation for carbon, or the name of this carbon, is carbon 12. If you have stable and unstable isotopes, typically what you need to remember is that the larger the isotope, the nucleus of that isotope is, the more unstable it is likely to be, and we call that radioactive. So just one more time, how to look at these notations. We've already been practicing writing isotope notations, though we didn't call it that. The element name symbol goes in the middle. And then in your upper left, you're going to have your mass number. And your lower left, you're going to have your atomic number. Now, here's where it gets a little tricky, okay? So because an individual atom can have a different number of neutrons, it may have a different mass number. For example, carbon 12 is the atom that you see on the periodic table, but carbon-14 is an isotope of carbon-12. How do I know that? Because this 14 represents the mass number. This 12 represents the mass number here. So carbon-12 actually has 2 less neutrons than carbon-14. Remember, if we do mass minus the atomic number, and the atomic number for carbon is 6, so 12 minus 6 is 6 neutrons, and that's what we see on the periodic table. But this one, 14, if the mass number is 14 minus the atomic number of 6, then that's going to give you 8 neutrons. So carbon-12 has 6 neutrons, carbon-14 has 8 neutrons. Now, fortunately, we're given the mass number, so all we have to do is look at the periodic table, find the atomic number, and then we can see that there's a difference of 2 neutrons between these two. Uranium-235. If you look on the periodic table, you will see that the mass of uranium on the periodic table is 238. So uranium-235 is an isotope of uranium. So the main difference that you should notice between an atom and an isotope, 2 differences actually. The first difference is that an atom has the mass is what you see on the periodic table, while an isotope has a different mass number. And then an isotope has a different number of neutrons than an atom does. So let's look at these 2 examples. So this is carbon-12 right here, and this is carbon-14. Now they've broken this down for us. Carbon-12, 12 is the mass number, so it has 6 neutrons, 6 protons, and 6 electrons. And if you really wanted to count these neutrons, you could see 1, 2, 3, 4, 5, 6. For carbon-14, 14 is the mass number, so carbon-14 has 8 neutrons, 6 protons, and 6 electrons. And again, you could count them: 1, 2, 3, 4, 5, 6, 7, 8. Notice that the number of protons doesn't change. And remember that the number of protons is what tells you which atom it is. So if you have the same number of protons with a different number of neutrons, then you are looking at an isotope of an atom. All right, let's look at this lithium-6 and lithium-7. Lithium-6, if you look down here in the bottom, the mass number is 6. It has 3 protons, so it only has 3 neutrons. 1, 2, 3, and that's what you find on the periodic table. However, lithium-7 has a mass of 7, so it has 3 protons, the same as lithium-6. That's how you know it's lithium. But it has 4 neutrons. 1, 2, 3, 4. So lithium-7 is the isotope. Okay, let's look at chlorine-37. Chlorine-37, the mass is 37, so the atomic number is 17. If you look on the periodic table or right here, it gives it to you. The mass is 37, gives it to you again. That means that you have 17 protons, 17 electrons, and then 37 minus 17, that gives you 20 neutrons. This is an isotope of chlorine because chlorine's mass on the periodic table is 35. So once again, isotopes are atoms of the same element, and they have different numbers of neutrons. This means that they have different mass numbers. For example, right here you have carbon-12, and here you have carbon-14. And all you have to do to tell which one is the isotope is to look at the mass number on the periodic table. The one that is on the periodic table is the atom, in this case carbon-12. The one that is not on the periodic table is the isotope. Okay, so this is a look at some practice that you are going to have to do where you use the periodic table to help you fill in a chart. And so here it's giving you the number of protons, the number of neutrons, and the number of electrons. So if you look at the number of protons, you can determine which element it is. And I can tell you that that is oxygen. Its symbol is O. Its atomic number is 8. Its atomic mass number is 16. And we're not really worried about charges right now. It gives you potassium and the atomic mass number. So you have to figure out the symbol, atomic number, and so on. Look at this bottom one this second one from the bottom. It gives you the number of neutrons and it tells you that it's bromine. But you have to be careful because remember that the number of protons and electrons is the same as the atomic number. So this number of neutron may or may not match what is on the periodic table. So this is the completed chart. And so you're going to have some practice where you look at the periodic table and you'll be given a chart much like this with some blanks and you have to figure out what number goes there. Just as a reminder, the number of protons and electrons should be the same on these charts. Okay, so in review, because isotopes exist, they have to use atomic weight for elements, and you know what? We really don't have to get into that, so we're going to skip that. Just so you know, Dmitri Mendeleev developed the periodic table, and the periodic table is arranged according to atomic number, and that's all we need to know about that right now. So